300-degree pencil melts nicely. 400-degree dropped out of the holder. We are not at 400. We are back here on the heel actually. Just barely at 400 on the heel. So I think this is probably ready to start welding. I use a Studi, S-T-O-O-D-Y manufacturing rod. It's made specifically for building up worn parts on heavy equipment, so it has very good impact resistance. If you stack up a few layers, it'll get up around 31 points Rockwell, which is pretty hard. Now the face of an anvil ranges from 45 points Rockwell to 50 or 52 points Rockwell. A typical hammer face is 40 to 42 points Rockwell, they tell me. So this is not quite as hard as the hammer face off the forge when it was built. But for my money that's okay, because I'm repairing the edge, and the edge wouldn't be repaired if it hadn't broken off. And hardness comes at a cost of reduced ductility, reduced resistance to impact in some ways. So it seems to me a reasonable choice. I could use a hard-facing rod, which will get up 55 to 60 points Rockwell, but that stuff does tend to crack. A little scary on an anvil with a hardened face. So you probably saw me backstepping the welding process. What that is from the origination point of the weld, moving forward with a short bead. You then drop back 2 or 3 of those bead lengths, originate another weld and come forward, stopping well short of the beginning of the previous bead. Back up 2 or 3 bead lengths, originate a weld, move forward, stop short from the prior bead. That way you're not pushing a huge heat gain forward, getting increasingly hot, increasingly hot, increasingly hot, and over-tempering, drawing too much of the hardness out of the adjoining material. I'm grinding with a cup stone. Let me grab that and show you what that looks like. So this is a fairly well worn cup stone on a 7-inch grinder. The cup stone provides a surface that stays in a plane. So as I'm leaning on this, I'm careful to keep it flat and not rotate the machine. I'm careful to keep it moving. I try to bring both edges down at once, and as I begin to make contact with the face, I know I'm getting closer and closer to where I need to stop. I'll work on the edges some more, bring those up to where they're straight with the sides of the anvil. It's tedious, it's slow, it's dirty, it's got to be done. I'm optimistic. I think I've got a good scald on the preheat, on the welding. So I don't know if you can see this, but I'm going to grind the sides of this repair now, and I don't want my grinder to be running down onto the side of the anvil and putting scuff marks and sander marks down onto the body of this thing, and that's just an aesthetic concern. Probably it's about 40% silly. The anvil won't care, the function won't be impaired. In a very short period of time, any of those marks will be obliterated by work and rust, frankly, in a shop. But still, I would like to have a pretty nice clean line between the area that's been worked and the area that hasn't been worked. So I've just clamped a piece of 1/4x3 on here, and I'll just grind. That'll provide a bumper to the edge of the grinder and hopefully keep it looking good. Pretty nice. Not much daylight through there. So this is a worn out flap disc. Doesn't remove much material, just sort of polishes. It was 80 grit to begin with. It's much finer than that now. Removing very little stock. Back is starting to hurt. This should be higher. Very good. I'm going to polish it now. Fibrotex surface finish. I don't know what in the world that material is, and it does wear out, but it'll last a while on this anvil face, and it'll bring it up to a pretty high gloss, get rid of most of the sanding scratches. And when you're forging hot iron, the iron will get rid of most of the sanding scratches over time.